Hello, hello, hello. Count Sake here, back with another shortest path solver thing. Well, it's a live stream. Anyway, so yeah, it's been a while. I actually don't even remember when is the last time I actually uploaded one of these. Let me go check. Yeah, because I'm sorry. Look, you know, you have stuff to do, and then Christmas hits you. So obviously you had no time to do anything. Anyway, so yeah. Anyway, let's go ahead and I'll go ahead and say this. I don't really have much to do. The reason why one of the things that I really wanted to do, and it's in a separate part, was to actually I actually wanted to finish this in 20 parts. But obviously the 19th episode is not a lot to work with, especially when I feel like I needed to do a lot more. And well, yeah, I try to avoid going over I try to avoid going over 3 hours, even though I kind of do it a lot. But then again, that's how I kind of end up doing things. Well, but if that's the case, then whatever. But yeah, I try to make sure I wanted to be able to complete everything by part 20. However, I don't believe I didn't I when I realized something, I actually still feel like I want to do something, and that is not just the instructions. It is some sort of controls UI, some sort of controls UI for the player while they're inside the graph the graph thing. Yeah, I wanted to do that because, well, let's face it, the controls can probably be very confusing, especially since this is kind of intended for math people. So I kind of intend to make some controls UI. Um, Another thing that I also need to do is actually um, make an animated title page, which is actually probably the thing that I want to do, which I guess that will go under title page. So yeah, I guess I might as well go ahead and start right now because I mean it's been a while. Where is it? The scenes. There we go. Title page. And go and save because yeah. Okay. So what is it that I'm going to be doing? I kind of imagined it like a wave. That in the title page that there would be it's like some sort of wave of, let's say, what is it? A wave of just a I don't know. It's hard for me to explain. It's just a wave of I wanted to. I'm having a very difficult time explaining this. I wanted to follow some sort of sine wave kind of motion. Let me get out Desmos to maybe explain what I'm trying to say here. So I have sine of x minus a actually, where a, and if I kind of wanted to do something like this, except extend it to the third dimension or something. All right, well, I finally can talk again. Oh, jeez. Well, all right, forgive me again. I may have to come back. Anyway, yeah, this is not actually a game. It's more of a program than a game. It specifically revolves around a math concept in graph theory where you try to find the shortest path between in a graph. Well, you might think of a graph as since most people know graphs as something like this. Well, yeah, something like this. But this is not the type of graph that I'm talking about. In graph theory, I guess I might as well look it up. Graph theory. Yeah, these are graphs. These are the graphs that I'm talking about. You might not know about them, but yeah, it's kind of what I'm doing. Anyway, so yeah, this is right now. I'm currently almost done with it. I'm getting near the end. I guess I might as well also show you. I guess I might as well show the stuff that I've done. All right, I forgot I can actually build this because it's very close to pretty much being done. So I'll go ahead and build it so you can actually see what the program actually looks like. All right, come on. All right. So yeah, this is the program made with Unity because, well, I know it. I'm still working on this title page. It looks rather bland to me. I feel like I need to actually add to it, which is what I'm doing in this video. And well, if I go into start, I could actually have some save files, and let's say I want to load up the Tesseract. And yeah, we have a graph in 3D space. I understand a little because I have the I understand a little because I have the brain of a stupid cat. Well, it's okay. It's more of something you won't really ever hear about until like you're in college. Yeah, I mean, graph theory. But basically, the idea is what this does. It allows you to basically build any graph that you want. You can create vertices, and then you can connect them. You can make lines and whatever. And yeah, that's what this thing can does. It's technically a model, a 3D model. It can almost count as a 3D model thing, but you can't really add faces, whatever. But yeah, it basically can solve for all the shortest paths between any two vertices. As you can see here, it would be a kind of a nightmare to actually find the shortest path to between these 2 points. But with my program, we can solve for it. And actually, it would be an absolute nightmare to do in this case because there are actually 24 different paths that can actually, or is it 24 or 25? S24. Okay. There are 24 different paths to this between these 2 points. That is, yeah, this is basically what the program does. It can solve for the shortest path between any 2 points, and yeah. And why are you making a school project? No, I'm a nerd. Okay, the reason why I'm making this is because I'm more of a nerd. I love coding, and well, I thought of it as a fun challenge. I'm kind of going over the top with this program, if I would have to say so myself. It's actually just kind of, I don't know. I wanted to really make something good because my first ever program that I actually technically finished is actually just a reaction time program. It's kind of lame to me. I didn't find it very good. But if anything, yeah, with this, I kind of have some things. Yeah, what am I trying to say here? I basically just wanted to see how I would do in making one of these. And well, right now I plan on adding some sort of animated look to the title screen. Like I'm gonna make a sine wave right here. Just ignore the stuff on the side. It doesn't really matter too much. I basically kind of want to make a waving kind of motion in the front. And well, I'm not sure how well I'm gonna do at that because let's just say I'm not very good. So it will you sell it? But you know I'll make but it okay what will you sell it? I'll buy it. I'll make it a cat. I want to see the shortest path. Okay, I don't believe I'm gonna make. I don't. It's not gonna be sold for money. I'm gonna make. It's just a free program. After all, I'm very certain that there are other programs that already exist that can do this. I'm just gonna make it a free program and kind of just release it on my YouTube channel. Have a video of it. Yeah, that's all I want to do. I don't actually plan on really making it like a product that you have to purchase. I'm gonna give it out for free, basically. But obviously, I do also need to put my name in this because it's my program. I put a lot of time into making this. As you notice that there are 19 parts in this. So yeah, I'll have a oh my gosh. I'll have like some sort of video where I do an official release. And yeah. So I guess right now I'm gonna go ahead and continue on. So basically what I want to do here, I'm gonna actually basically what I'm trying to say here. I'm basically making a for loop and generating some sort of I'm generating a field of vertices specifically at every what are those points called? I forgot what the points that are exactly like on I don't know I forgot what those points are called. Dang it. I know like the points exactly on a, like for example, 1 1. It's not like both of these are integers. They both have to be integers. So it's like it can't be like this. It's only specifically points that are on like they're like on like at an intersection of lines. In a few years, could I use this to cheat on homework? I mean, sure, if you want. Yeah, I mean, if you want, go ahead. Not my problem if you get caught though. All right. Anyway, so vertex. So what this is going to be is we're going to have a vertex field x range, and we're going to take the minimum value, set it equal to this. Oh, right, it's an integer. Okay, I guess we're gonna have to. I guess this bit of code is actually useless. So yeah, we can just go ahead and do that. Get rid of that. All of that. It was completely useless because we actually just need to convert it to an integer right there. Is there such thing as an int vector? No, there is not. So I guess I'll go ahead and okay. While x is less than, or would it be less than or equal to, or would it just be less than? Is this math or what? Technically, graph theory is a math subject. It is not a subject. It's under math. But what I'm doing here is coding. And basically, what this is supposed to do, it gets the minimum value that I set inside of this vector, which is basically two numbers. This vector 2, what it basically means is that we just have two numbers, two separate numbers. Well, yeah, I'm terrible at explaining this. But you can basically this vector 2, what this is a vector. I'm terrible at explaining this. Okay, it's a list of two numbers. That's all it is. How we reference the first in code for specifically Unity, how we reference the minimum value, which is what I have it, the minimum value in this case. In this case, it's the minimum value because it's a range. How I access that is by putting this dot x. And actually, if I wanted to, I could put dot y, but that would be the maximum value. So I'm going to not do that. So while x is less than the integer value of the vertex x range, y, this is the maximum value in an integer, we're going to go ahead and do some stuff. Wait, why is it expecting a... What? Oh, right. Okay, then we do x plus plus. Okay. yeah, I'm sorry if I'm terrible at explaining stuff, but basically we're now going to have another for loop. We're going to take an int y. This is actually going to, instead we're going to do int vertex field y range. I gotta go or my grandma's gonna beat me. See ya. All right, I'll see you, depth. Okay. See ya. All right, so we have a y range and we dot x while it set it to the minimum value, obviously. And then actually hold on, wait a second. Hold on. Right, Unity is not actually set have its the horizontal plane in Unity is actually the XZ. So right, this probably should be changed to a Z, the Z, because it's supposed to be along the horizontal plane. Yeah. Okay. Anyway, this is going to be the Z. Then what we want to do is while y is less than the integer vertex field z range dot y, we want to do y plus plus. Basically, this should cover every single thing. I can generate any possible I can generate basically as many vertices as I want. But now what I need to do is actually reference my graph editor script graph editor dot script, and we're going to create a vertex. And well, all we need to do is make a new vector 3, and this vector 3 will consist of the x. Oof, that's a bit of a bad name. Okay, I'm gonna instead, can I do it like this? I'm gonna make this a capital X and make this a capital Y so that way it won't get confused. Actually, it should be a capital Z because, yeah, okay, so here we have X, capital X, and this one's going to be a 0F and a Z. So that's actually what we need to do. And all right, I'm a bit yeah, right, I forgot I need to give it a name. I just call it A. It doesn't matter. The name doesn't matter in this case because I can name it anything. Yeah, okay, so that should basically cover everything. I'm not sure if I should put this in the start necessarily. All right, I guess I'll go ahead and I'll just go ahead and play it and see what happens. Right, I forgot to actually do something. Oh, right, graph editor script does not exist. It doesn't exist. Actually, all we need is a reference to the vector. All we just need is a public. Yeah, all we need is a reference to the. Do we have a? Wait, hold on. I need to check what's here. Okay, in our game manager, we have this. Our main camera, we don't have. Okay, we don't have the special objects list. Okay, it doesn't exist. So actually, we need to have a prefab public. This is going to be a game object. This is going to be the vertex prefab because we do not have access to our other scripts. The only scripts that we have within this are actually the stuff because everything else is like mono behavior and whatnot. All that actually goes into these things. So that's a bit of a problem on my part. Which is why maybe most of the managers actually should have not been a mono behavior script. They probably should have been. They can still use the Unity engine. However, they should not have been using mono behavior, because if I put mono behavior here, it means that I'm going to have to actually attach it to an object to actually make it work. Or I need to actually attach it to an object or some sort. But in my case, because let me go ahead and look at my graph editor script. The graph editor script, does it have a vertex start? Oh, it has a vertex awake. Okay, I can't actually change it already. I've already put too much effort. I would have to do too much to actually fix that. So in a sense, I just need a reference to the, yeah, this is basically, I basically just need a reference to the vertex prefab. All right, and well, oof, okay. This is a bit of an awkward. This is a bit awkward. Okay, okay, okay. I'm just realizing now that because I do not have access to a lot of scripts, in a sense, I've kind of just destroyed I've destroyed a bunch of stuff. Yeah, this is why you kind of need to not put stuff in mono behavior. I kind of have a huge issue right now. I can make the vertices, but the thing is now I need to also think about the edges between these vertices. It's basically a little. I'm having a bit of some time actually. I'm having a little bit of some difficulty actually thinking about how this is going to be done. So, but good thing I'm live streaming this. That way you can help me figure it out, so I can help myself figure it out. Okay. Anyway, so what is it that I was planning? So in our prefab, we have a vertex model, and we open our prefab. It has the vertex script. It also has a vertex interaction, which we actually don't really need. But all we need is a reference to. So oh wait, we need to actually we still need a reference to the vertex prefab, and we also need a public game object, and this is going to be the edge prefab, and this is going to be a reference to edge prefab. We don't. This one is actually honestly we're going to have to recreate our create a vertex and create a edge kind of thing. But luckily for us, it's actually rather simple. All we need to do is this. Wait a second. Okay. Actually, this is a bit of some issue. Okay, this is a bit awkward now. I have to do some brainstorming. Okay, my problem now is that I'm not thinking, okay, I should probably not think about create. Okay, I'm gonna have a private create vertex, its own create vertex, and all we need a private void create vertex. Actually, should I? Oh yeah, we should probably return the vertex because so that way we can just add it to the list of animate vertices. All right, and with that, we need to have yeah, let's make it easy. We're gonna have a float x, a float y, and a float z. That's all we need. Make it easy for ourselves. Actually, let's do an x position. We have y position and z position. Just do it like this. That way I don't accidentally make myself a terrible thing. So first off, we're going to actually do we're going to return a get component. But okay, we're going to get, first off, we're going to make a game object. Actually, we could do this in kind of one line. Return get component vertex dot. Okay, we can do this in okay, I'm trying to remember. Okay, it's been a while since I've coded, so forgive me if I'm terrible. Instantiate dot. Okay, so we're gonna do a vertex prefab. We're gonna reference the vertex prefab. Our parent, okay, we actually are going to have a reference to that. So I'm gonna just make a private reference because why not? We're gonna have a serialized field so that way we can actually edit it in the thing. So private vector, not vector2, private transform. This is going to be the vertex field parent. I could just call it a field parent, actually, the field parent. Then we can pass this on to the field parent, and what's the other? Okay, our position. Okay, that's where we do a new vector through vector 3, and then we pass in our x position, our y position, and our z position. And with that, we also want to do a Quaternion identity. We don't need any rotation. Let me actually hold on a second. This doesn't look right. We should do it like this, and we can put the parent last. That looks about right. But of course, we can't actually convert that, so we need to actually do a get component kind of thing. This is a rather long line, but it can fit, and this is going to be a vertex. Yep, and that is it. We literally just did our own create vertex thing. Now I actually could. Nah, never mind. I'll do animate vertices.add. All right, animate vertices.add, and then what we do is we do our create vertex, and we pass in our x, 0f, and z. That's all we need to do. And with that, let's see if we can generate our field. Hopefully. Right, okay, I'm smart. I need to actually do stuff. Null, obviously I'm going to have a null reference, so I need to first create an empty. This one we're going to reset the transform. Let me make sure. Oh gosh, okay, actually, we can keep it, so we keep it there. This is going to be the field. And let me go ahead and get our script. Here we have our title page, and we basically, we can assign it to the field, why not? We need our vertex prefab, and in our prefabs, we also need to get our vertex prefab and our edge prefab, and lastly, our field parent. Why not? We'll just make it this object. Probably, since it's the, I could probably just, I'll get rid of it because I actually don't need it. All I need to do is set this to transform. You know what? Game object.transform, because I don't feel very confident by just putting transform. Okay, anyway, with that, because you're not actually exactly going to be, since the camera is kind of like, when we focus on the main camera, since the camera is like kind of like that, we need to do a bit of some. We don't actually want it. Where is the main camera located? It's located at +1. Okay, so let me reset the transform here. Okay. Actually, I believe we actually would like to raise it up a bit. Maybe like 5 or something. Well, we can adjust this later, but basically I don't want this to go from 0 to 0, otherwise it's kind of lame. I'll go from -10 to +10, and again, we don't really need the z. Oh wait, x, z. We can start at 0, and then this one could go up to 10. But let's just see if this script actually creates okay. That looks absolutely terrible. Okay. Yeah, okay. Anyway, what's this? What? What? Okay. Oh, okay, hold on a second. The game manager, okay, first off, we need to make sure that if UI manager.script is not equal to null, we'll go ahead and do this. Just a little bit of some code, that way we don't actually end up causing ourselves, giving ourselves a wreck or something. All right, and let me actually make sure something also. If I do any sort of clicking, all right. All right, under Vertex Animate, first off, I would like to say that is absolutely terrible. Everything looks really ugly. I would actually like to do ×2 and see what that looks like. Whoops, ×2, and just see what it looks like. Yeah, I kind of just repeated myself there. Wow. Anyway, let's go ahead and see. But it still looks too cramped up. Let's now do ×5. That way, because I don't want it to be a. Actually, I can make a private. I can make a private field. Like I can make a private float here. Private float, and this is going to be spacing. It's going to be the vertex field underscore spacing. Okay, it's a bit. So we're going to do that vertex field spacing right there, and vertex field spacing right there. It's going to actually, well, I can keep it a private, why not? All right, anyway, enter our anime. Actually, our animate okay, wait, we're just going to test this first. We're going to set this to 5, like so. It could actually technically be a 0. Oh, okay, that looks a lot better. That looks a lot nicer. All right. So we basically now have all of these. We also would like to make sure that this is a private. I don't believe it needs to be public. And well, I completely forgot to do one last, wait. Oh, I can make it this. Actually, I actually forgot to make sure that all the vertices are there. Oh, it's okay. So it's 200. And basically, we kind of, let me go ahead and look in the field. So this one should start, yeah, exactly at -50. And if we go down by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oof. Hold on a second. Okay, hold on. Wait. Okay, so that is actually a bit of a problem. The field should. Huh. So I believe that because of that, I'm going to actually have that say less than or equal to, because it appears that it didn't actually start exactly where I wanted it to, or it didn't end where I wanted to, because it should be. Okay, it starts at -50. Oops. 10, 45, 50. All right, that's exactly how I wanted it. And lastly, it should. All right, no, it's still definitely not. Should be less than or equal to. There we go. All right, with that, we basically now have all the vertices on here. And well, there's quite a lot. There's actually quite a lot of vertices. There's a lot of animated vertices. It's quite a lot of them. If I was completely honest, obviously not all of these vertices are needed. However, not all of these vertices are needed. However, it would be nice to actually see something. Okay, but from the game's perspective, yeah, it's pretty wide enough field. 231. Why is it 231? Oh, it's two. Why is it 231? This is a little bit of a strange number, if you ask me. Shouldn't it be exactly a? I guess whatever. I'll just go with it. It doesn't matter. It doesn't matter. Generating the field is not too much of a problem with me. For me, the problem is actually getting all of these vertices. And well, yeah, okay. So with that, we basically generated our field. And here we're going to actually have a private float. This one is going to be the distant. What is it going to be called? Float. This is the function input or whatever. Yeah, we're going to call it the function input. This is basically what this is basically the value inputted for the. Okay, this is actually rather hard to explain. But now what we need to do, what I'm going to be doing is I'm going to have a void update right here. Our void update, and well, let's just say, okay, I'm a little annoyed that that it has those void updates and whatever. Okay. But with that, we have in our void update, function input will be increasing plus equals by time delta time, and of course we want to do some sort of thing. So while if function input is greater than or equal to math f dot pi, actually this is going to be specifically 2 times pi. We want to set function input equal to 0. That's actually how I want to do it. So first off, I also should probably mention that function input should be equal to 0. Well, basically, every single vertex, its y position will be set with some sort of function. But should I make that its own function, or should I put it here? I wonder. I don't know. I'll just put it here. No. Well, we'll start it like this. I'm going to have it like this. We have a function, not function input. What we want is okay, we're taking a sign function. That's what I'm trying to do here. So I kind of would like a bit of some customizability. So here we're gonna have this is actually let me go ahead and I'm doing terrible explaining this. This is going to be the vertex field properties. Okay, let me check. Okay, vertex field properties all the way up to there. And the vertex field properties. Actually, I kind of like this format. Okay, and then here I'm going to have this is going to be the sine wave properties like so. And well, I'll go ahead. Actually, I could just do that. Shift Control D on a line, and it'll basically duplicate the line. And here we're going to have a private variable. Actually, the float here is a sine wave property, and here we're going to have a private float. This is going to be amp, and this is going to be the amplitude like that. Let me go ahead and remind myself using Desmos over here in the calculator. Let me get it out. So here we have a sine wave. basically we have a sine wave. The one thing that we want to multiply to the amplitude refers to whatever you multiply to this sine function. So yeah, this is actually something. However, we can also, and basically you can imagine it like this. You can imagine that for every point on this graph, whatever it may be, for every point, it will basically, as time goes, we have like a time variable, so we're going to put this as t, and basically time will just flow constantly. But in my case, it's going to go from exactly from 0 to 2 pi. I have 2 pi for a reason. If I actually make it this step, never mind, I'm not going to do that. But basically, this should only go like this. Let me go ahead and speed this up so that way you can actually see. As you might notice, it actually doesn't look like it's looping. If this was like some other number, let's say like 1, it would be very obvious that there's a jump. So there's a reason why I'm actually putting this as 0. That way you would actually not notice that there's like a sudden jump in all of these. So basically, this is our function that we want to use. This is our sine function. We have our amplitude. This is our amplitude. And well, we can change this to be as however large we want it to be, however high we want these vertices to go, and whatnot. We can even make it like shorter if we wanted to, if we just like want to make it look more casual and whatnot. But yeah, basically you can do that. I'm not sure if I would like to add a little bit of a random factor to this. It might just cause too much. It might be a little too taxing on the computer. After all, this is a script animation. I don't want it to be too calculation heavy, and it's using a sine function. So yeah, I probably should just stick to a constant, to just using the amplitude rather than generating a random value for this amplitude. Anyway, so we have this, and what we have to do now is create our function right here. And well, whatever. I might as well make the function here. This is going to be the sine. It's going to be a private. Actually, this should be a float. Our wave function. I probably should be. I'll just call it function. I would like to call it a wave function, but then that's actually something in physics. It's the wave function is actually a physics thing, so I might actually be. I'm going to call it the sine. Just call it the sine wave. Anyway, we basically have an input x. We actually have a float, and this is going to be the input value. We're going to have it in all caps, so that way we don't actually get confused with something else. And well, we basically return mathf. I mean, I could, if I want, do a float, and this is going to be the amplitude, but I'll by default set this equal to amplitude. It must be a constant. Are you serious? Okay, never mind. Okay, fine. I'm going to do it like this. Amplitude, and multiply this by mathf.sine. Okay, the input is in radians, so that's a bit awkward. So we're going to do mathf. We're going to do degree, or do you? Oh gosh, this just made it so much awkward. Oh, actually, I realized we just need to put input. We don't actually need to worry about input value because I'm using radians in my calculation. Okay, now I'm wondering. I just realized. Would it be better to use this mathf.pi, or would it be better to just use 360 degrees? I bet. Okay, I'm just gonna do two pi. I'm just gonna do it like that and see whatever it might be. I don't really care, but anything. if anything, we're going to have this. We have a function input, we have an amplitude, and well, I actually should probably make this a, I'm going to call it, instead of doing it, I'm going to call it the wave amplitude, like so, and then I'll do a serialized field like that. And of course, input value, and this is the float, the shift. Did I just accidentally spell out a word? Horizontal shift. Horizontal shift. That one is referring to the time or whatever it is. Actually, what am I doing? This is literally just going to be minus function input. There we go. And now we have to do a for each loop. Actually, hold on a second. Hold on a second. Why do I make this a vertex? Okay, I can just do a game object. I don't need no vertex. I can just turn a game. I don't even need this to return a game. I don't even need to do that. I can just call the function create the vertex. I can just create the vertex here, and within this, we don't need to get component. This is completely worthless. It's a completely worthless thing. And with that, why am I here? What? Oh, there. That's where it is. Okay, so here, what we need to do is we need to do this. Add. Oh no, not that. We don't just do add. We want to do it. There we go. Okay, so what we want to do is do animate vertices dot. What am I doing? Come on, I'm not doing very well here. Okay, animate vertices dot add, and we pass in the game object. That's all we need to do. There's nothing else that we needed to do. Wow. Okay. I also need to mention that I technically still have yet to do the connections, the connected edges between them. Yeah. But I'm just trying to get out I just kind of want to see if I can get the sine wave motion, because once we do that, we'll basically have what looks like a sine wave, or some sort of sine wave motion. I just realized there's a bit of an some sort of awkwardness in my combination. I'm not just going to be using this. I technically am having a function. I'm going to call it, let me make this a function, a, t, and we have an x. Basically, this is our function. And well, let's say we do a, we're going to do I'll do c, and then we'll do x, where c is a slider, and well, yeah, you can do whatever we want. And basically, let me call this a sub 1. This is going to be the s sub 1. So this is going to be c sub 1. We'll start it off like this. Hold on, let me make sure that my audio, okay, good. Okay, we're going to start it off like this. We have a c sub 1, and we also have an a sub 1. Oh, S sub 1, sorry, my bad. So basically we have this. We have a sort of shift value, and we have an amplitude. We can give it any amplitude, we can give it whatever we want. We can do that. However, we can also duplicate this, and let's say now we're going to have an a sub 2 and an s sub 2. I won't make this complicated. I'll just make everything the same amplitude, because I don't need any of this. Okay, so basically now I'm terrible at this. Okay, so basically now we have something rather interesting. We can actually offset these by some sort of value. It doesn't really matter how much, but something I would like to do is something I would like to do is know how many, I basically want to take the range, the range of these two, and sort of like divide that by some sort of value. Now, there's a concept, I think it's called the period, or I don't know. I think the period is the amount. Let me get rid of one of these sine waves. We have a normal sine wave. So basically, the period is the amount of how long it takes until the pattern kind of repeats itself. That is one period. So here, one period is 2 pi long. And basically, I kind of need to make some sort of constant. Basically, have some sort of constant. Now, I don't actually want to calculate that constant every single time necessarily. I'm just going to make that its own private float. This is going to be the wave axis, wave offset, wave x-axis, shift offset for along this is going to be along the x-axis. Okay. Oh, hold on a second. This is supposed to be the other way around. This is supposed to be this minus the input value. The function input is the main part. This is actually our x. This is actually the x value. It's going to be determining the height. I should probably, you know what? For each game object, vertex in vertex obj vertex in what is the animate vertices. Basically, we want to set its position. So we want to do object vertex dot transform dot position is going to be set equal to a new vector 3. Hold on a second. I'm trying to see if there's something I can plus equals object vertex dot transform dot position, and we multiply this by this is just okay. This is just, wait, hold on a second. Transfer dot position, multiply this by a we add this. Okay, we take this, we add this by a sort of some sort of vector. This is terrible. Okay, I'm just gonna do I'm just gonna basically set this equal to a new vector 3, and then we do object vertex. Oh my god, transform dot position dot x. Then the y is actually going to be determined by sine wave. Sine wave, our input value, believe it or not, is actually going to be our input value depends on this offset. So we're going to actually do our wave shift offset x-axis. Now, here's my little bit of an issue. I kind of need to know how many is in each field. Because as of now, it just looks like everything is going to look exactly the same. So hold on a second. Okay. I hate these. I hate this, but those errors really bug me. They're not actually errors, they're just little warning signs, but whatever. Okay, you know what, fine, we'll just ignore that. Hold on a second, something's missing. Oh, the amplitude, there it is. Set this to 2. Oh, we actually didn't calculate the wave shift offset. Okay, in here, I'm basically, you know what, I'll just set the wave shift offset x-axis is going to be equal to, well, we're going to have an int. This is going to be the column num. It's going to be equal to 0. So we'll have column num divided by the period, which is actually 2 times mathf dot pi divided by the period of a sine wave. The reason why it's exactly this is because technically we're not altering how long the input is. If we actually wanted to do that, we would actually have to multiply this by some factor. We could make it longer, we can make it shorter, but we're not actually doing anything to the input to this part here, so we don't actually need to worry about it. So it's always going to be a 2 pi period. Okay, with that, yeah, column num is going to be equal to 0. However, our column num, we do not know exactly where that is. And we also want to do our int row num, and this is going to be equal to 0. And basically we do a row at the end Okay, you know what? Let's not check for that right now. We're gonna just leave it there for now. We're not gonna do anything with it we're not gonna do anything with it yet, but we will do something with it. So hear me out. All right, anyway, let me go ahead and save and let's play. Oh, my bad. Okay, so I completely forgot to do this. Object vertex dot transform dot position dot Z. I completely forgot to do that. My bad. That's why it only looked like there was a single row of vertices. So now everything has the exact same input. So this is a bit bad, but at least we know that it has the sine wave motion. However, you don't just do this by the wave shift offset. We also need to take into account the x position. We actually need to take into that. We need to put that into an account. Or is it the? Actually, no. We actually need to take into account the z position because that is our horizontal plate thing in this case. So yeah, we actually need to put that into our function, and hopefully that will actually. Hold on a second. Which way is this facing? Oh, it's facing the z direction. Okay, my bad. It's actually should be this. Actually, what happens if I add these two? Yeah, it's going to be minus. Let's see, add. I'll just see what it looks like. And with that, we have a sine wave motion. Okay, that's cute. Okay, it's a little cute, but let me make this to 4 or something. And that is hopefully this will look a lot nice. Let me set this to 1. Oh, my bad. That's the wrong one. That it's supposed to be this one. We're gonna set this to 1. All right, it looks cute. Yeah, it basically just looks cute. All right. Here's the thing. I kind of would like it such that the back actually goes a little higher. So I might actually do something with our the amplitude. But you know what? I'll before I do that, we basically okay. Okay, this column num, what this does. Actually, okay, I'm doing terrible at this. Okay, here's what we actually need to look at. We need to know how many vertices are in each column. That's exactly what we need to do. However, this is a bit awkward for my case because I actually do not know how many columns are, I do not know how many are in each column. So I kind of would like to modify my case here. I want to make this an array of some sort. No, that's not going to work. We have a list of game objects, but we're going to do a game object. Okay, no, this is not working. A list of game objects. Oh, no, you know what? Let me just do some counting. This is too complicated. Actually, it's not very complicated. It actually makes the code. Would it make the code shorter? I guess it would. But the idea is, my idea is if the at the end of this we do row num plus plus. Actually, we should do it by setting it to 1. If the column num will be set to 0, but the column we specifically do column num is set equal to 0, and row num will be set back equal to 1. And this will only happen if row num happens to be greater than some sort of value. But I have a feeling that it would have to do something with the vertex field vertex field z range dot x minus, we have to put this in parentheses, otherwise that so that we get order of operations vertex field dot z range. Actually, no, wait. And we also technically, whatever. Y is always going to be, and well, we basically want to convert this to an integer. Here we go. I have a feeling that's going to be what it is. That has to be what it is. But let me go ahead and check. It still looks like the same wave. I don't see any difference. Okay, this is not working. Okay. That's a bit awkward. Oh, plus is equal to 0. Plus plus, I am smart. Duh. Hold on a second. Okay, maybe I should up the wave amplitude so that way I can see things that might be easier to see. It's still not exactly okay. What's going on here? Column number. Oh, okay. Forgot order of operations. Right, that is actually very important. Order of operations. Okay. Hopefully. Hello? Any sort of why is it only on the last two that it actually has? I don't know. I'm gonna set this to 0. I'm just gonna set that to 0. Let me make this more drastic, that way I can actually see if there's any. There's what happened? I set the what? Okay, fine. Oh boy. Okay. Let me just generate a field and see it for myself. Okay. In this case, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And well, when we do it here, Z range is actually okay, so it actually should be it actually should start as a -1. Okay, so that way it goes to 0. All right, let's try that. Actually, no, it should start at 0. My bad. I am smart. Okay, I perfectly know what I'm doing. Man, this is actually a lot more difficult because I'm trying to figure out why is it that I'm trying to figure out why is it not making the wave some sort of wave pattern that I want. Okay, so the shift here, since we have only 2, it actually should be an offset by exactly pi. However, if we add a third one, this is actually going to be s sub 1 plus pi. We can have its own shift number and its own x. We're gonna add this one. It's 3. Well, this one's actually going to be S1, but now it's not pi. It's actually going to be, we're gonna do this. We're gonna put this with a S, and this one is going to be, this is going to be equal to pi, 2 pi divided by 3. Oh no, wait, 2 pi divided by 3? Oh no, it has to be 3 divided by 2 pi plus, well, S. Hold on, wait, what? Or is it pi? No, that's definitely not it, because it's not. Wait, what? It should be pi. It should be, wait. Huh. Okay, this should output a pi. Ah, that's what I was doing wrong. Okay. I am smart. Okay. This should be the other way around. Basically, I'm smart. Okay. Divided by the column number. There we go. That's why there was like barely any difference. Okay. Oof. Okay, that's a bit of an awkward one. We definitely. Yeah. Okay. We basically had an infinity. We had some sort of infinity in this. Um, we don't want to divide it specifically by. We don't want to. We don't want to divide this by 0. We want to divide it by 1. Otherwise, we're going to have some serious issues. Okay. Yeah. Anyway. Did I forget to save? Yes, I did. All right, I basically accidentally created an infinity in my code. So yeah, because I was dividing by 0. They still look pretty in sync to me, if you ask me. If you're asking me, I don't. Why is it not in sync? Just set this to 11. Okay, 0. Then it goes to 1. Then it goes 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, never mind. So I think it's to 1. To 1. Because we're smart. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, good. I had to actually count that on my fingers, otherwise my brain would be exploding. Let's just do a minus. Let's just do that. Wait a minute. Wait a minute. Hold on. My brain is exploding. What? Okay, no, it actually is supposed to be the X. However, okay, okay. Right, okay. This is not supposed to be the column number. Wait, is it? No, it's supposed to be the row number. I am smart. Do I even need this column number anymore? Oh my gosh. I'll do it like this. Vertex z range y minus vertex field C range x plus 1. We'll make sure that these are int. Also make sure that this is an integer. There we go. Hopefully now. I don't get anything. Okay. Okay, because I want the wave to, I don't want it to be like everything is in line, aligned. Like I don't want it to be a single wave. I want it to slightly like be offset by some amount, like this. I want it to somewhat look like this, except 3D. But I'm not really getting that, and that's what's confusing me a bit. Okay, so wait, the offset. Okay, the offset only needs to be calculated if we change. If we change the, oh, we actually do need to calculate the offset. No, this is supposed to be the z-axis. What? Z-axis. 2 pi divided by the row number. There are a total of 11 waves, all right? In this case, there are a total of 11 waves. So we basically have sorry, I'm kind of trying to brainstorm this. Oh, wrong one. It's going to be 3s. Okay, that's definitely not the case. But yeah, that's definitely, take s sub 1 plus this, s sub 2 plus this, s sub 3 plus this. This is only 3, so we're actually changing that to 4. Wait a minute. Hold on. This is a very interesting pattern here. Okay, so here, they're all evenly spaced, and it just count, and that depends on the number of wave functions you have. Oh, we only need to calculate it once. I am stupid. Why am I calculating for, okay, I am definitely stupid. Okay, all we need to do is take this, divided by this. We also need to make sure that this is grouped up. Otherwise, we're going to have some terrible, terrible stuff happening. What? What doesn't exist? Okay. We also don't need this column number. And instead of doing what I've been doing, all I just need to do is multiply this. All I need to do is multiply this one by the wave shift offset. That's all I needed to, that's all I'm very certain. Okay. If I don't, if I'm wrong, then, oh boy. Okay, I am smart. It's supposed to be the row number. I am smart. Okay, I am very smart. I definitely know exactly how, I know exactly what I'm doing. I definitely know how to code. Okay. Actually, that's more of math because you need to pay attention. I definitely know my math. Okay. There we go. Yes. 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 It's beautiful. It's beautiful. Oh my gosh. Yes. Yes. Oh my gosh. It's beautiful. It's a bunch of vertices floating. Okay. I'll make this 1.25. Okay. Uh, I know. I don't know why. I feel like I want to make a bit of some randomness in this. I feel like I want to do a bit of some randomness, but at the same time, I don't want it to be taxing on the. I don't want it to be. I don't want it to be taxing on the person's end, on the user's end, because let's face it, we're using a sine function. Then we also have to calculate for the. I'm very certain that I am very certain that Unity does a sort of calculation to determine pi, and I'm also very certain that that unless I probably should look that up myself. Uh, okay, how does Unity calculate pi? If it does, actually, let me go ahead and see what it is. So let me see how it is. There's it's a float. But how does it actually determine the numbers for it? Okay, I am not sure. You know what? Here's the thing. There are quite a bit of things I can have here. There are really quite a lot of stuff. There's really quite a lot of things that I can actually have here. Instead of making this a float, I'm gonna make this a vector too. Now that might sound strange, but I'm gonna actually do a float random float amplitude equal to a random, returns a random number. Oh, actually no. Not state, range. And all we need to do is pass in, okay, it's the minimum. Okay, our minimum is going to be the wave amplitude dot x, and we have our wave amplitude dot y. I don't want to add too much randomness into this, otherwise we're going to have a bit of some awkwardness. So we're going to actually have this instead take the amplitude, and yeah, this is what I feel like doing. I feel like the amplitude should be from 1 all the way up to 2. It actually, and hopefully it can hopefully this won't be, I have created a quantum wave, a quantum field wave. Okay, never mind. That looks terrible. Never mind. Okay, forgive me for that. That looked absolutely terrible. Let's forget that ever happened. Uh, Wave amplitude. I completely forgot that. I completely forgot that the wave amplitude is actually calculated in this sense every. Actually, let me do this. Float amplitude. The amplitude is only going to be calculated. Oof. Okay, this is a bit awkward. Because now every single vertex has its own amplitude. I'm making this too complicated for myself. Let's not. I'm making this too complicated for myself. Let me not do this wave amp. Let's just multiply by the wave amplitude and have everything just have it be the same exact amplitude. All right. With that, I'm going to set this to 1.5, or actually, I'll try 7.5. Let's try that. Let's try that. And you know what? I feel like the camera, at least how it looks a little. I feel like I want to make it. I want to try and make this a bit larger. Let's try 20. Okay, we're starting to see a bit like of the edges over there. Actually, we can only just. I don't believe I want to do too large. I don't want to do a too large field. Otherwise, things are going to be a little chaotic and it's going to be like super taxing. All right. Now everything's looking a little too uniform. We might need to step this up. If we change it to 0 and just. If we change it to 2, it actually looks quite fine. 2 is actually quite fine, actually. I don't mind it. 3 is a bit too high. 2. Okay, I also would like to have. I might also want to have another serialized kind of field. A serialized field. This is a private float. This is going to be the wave speed. Yep, and with that, we basically multiply that by our. Hold on, before I'm trying to think. Okay, hold on a second. I don't want to end up just. Oof. Okay. I kind of realized that is definitely not a good idea to calculate every single frame. Actually, that we can actually just calculate it once and it will be perfectly fine. Actually, then we multiply this by wave speed. Let's try that. Hopefully, then, our wave speed is 0, so it actually gives us a completely static. If we speed this up, we can make this 10 times as fast. We can make it super ominously slow, but to me, 1 looks a little too slow. That looks too fast. Let's try 7.5. All right. Well, it looks nice. Well, basically, but the thing is, we still need to actually connect all of these vertices. Yup. Luckily for us, I said okay. Luckily for me, the edge script. Let me go ahead and go to that. If I'm not mistaken, the edge script calculates in an okay, fine. Rather than doing that, I'll just make a new script. A new script. It's going to be a title edge title. This that might sound a little strange, but that's because I'm going to have this specific one only be for edges that are on the title screen. Okay, the title edge basically has a private, actually we don't, private edge reference. This is going to be the edge script, and in our void start on the instant, our void start edge. Okay, basically edge script is equal to get component edge. Yeah, with that, all we need to do is do a void update. Just do a void update, and well, guess what? What we do is take the transform dot position, set this exactly equal. Basically, we just need to do edge script dot. Let me look at it. Update trans. Okay, all we need to do is do edge script dot update transform. That's all we need to do. That's all we need to do. All right, because of some things regarding some things. Okay, it's been almost 2 hours. Oh my gosh, it's like quite early in the morning. Okay, paint. I'm gonna open up Paint Tool Sci here. Now the reason is because I need to do some thinking. I basically have a field. I basically have some sort of field of vertices. So let me make a kind of a large, just some sort of field of edges or vertices. So here's the thing. We're going to have some sort of list like this. And well, we kind of basically have, you know what, I should probably just copy. Okay, I'm going to go ahead and just copy this, paste it like that. What? Okay, I'm going to go ahead and, okay, now we need to figure out how to actually connect all of these. That's my problem. I need to figure out how to connect these. But luckily, there is a pattern to how this works. When we go up, this is exactly how the, assuming that this lies on some sort of plane. Let me make an xy plane. This bottom one here should be the first one. This should be the first one. Then it goes like this and so on, all the way. And yeah, let me go ahead and make this opacity kind of low because we don't really need to see it. You basically need to see. You don't really need to see it. This one is the first one. This is going to be the first one. This is actually going to be index 0, 1, 2, 3, 4, and 5. And well, this is so basically in our code, this 0 and 5, the 0 and the 5 here is actually going to be our good old friend from here, the Z range. That is actually the Z range. This is supposed to be the, over here, this is going to be the, well, I guess we'll do it like this, the Z range. Give me if my handwriting looks terrible. And then if we do this all the way up to here, this is our X range. The X range, okay, hold on a second. X range, the X range. And well, this actually then goes to become 6. This goes to 6, 7, 8, 6, 7, 8, 9, 10. And well, yeah, yeah, it makes sense. And we basically want to connect with a vertex. We basically, what we do is whatever our Z range is, whatever our minimum and maximum is, we add this by the amount of vertices in each row, and we can connect to that vertex. Now my problem is on this end, well, there's nothing to connect to on this end. There's nothing to connect to. It's going to look rather ugly, or actually it's going to look rather ugly in code. So basically, what I want to do here on this very last row is if this one is the very last one in the range, we want to actually not calculate. We basically want to ignore that. All right, so that actually makes a lot of sense. Hopefully that makes a lot of sense. Otherwise, you're not going to understand what I'm going to do. Anyway, so let me go ahead and now create okay. What this does is create the vertex field, and it and then, well, okay, this one is creates a vertex. I'll comment this out later when off stream, so that way you don't have to see me creates the edges. All right, so now we actually now need to create a void, a function. We basically need to make a function for our create edge. So with that, create edge, and all we need is a reference. Okay, I see how it is. Let's see how it is. I see how it is. No, I'm not being salty or anything. I just see it. Actually, hold on a second. No. Wait, hold on. We don't need to do that. You don't need to worry about that at all. what we can do is take our game object and we can basically vertex 1 and we'll do game object vertex 2 and have the code do it for us. And underscore p2, actually I'll change it to this, edge underscore p1. Yeah, so yeah, this is how we're going to do it. So in this we create an edge, so we do instantiate, but first we actually want to do a, I'm going to set this equal to a game object. This is going to be the new edge and equal to this. And what we'll do is instantiate the edge prefab is equal to a actually this is going to be equal to vector, come on, vector 3.0 and a Quaternion identity, and lastly the game object.transform. And well, we now need to get component. We need to get reference to the edge script. So edge, or we could do new edge dot hold on. We'll do edge script is equal to new edge dot get component from new edge dot get component edge. There we go. And with that we do edge script dot p1 is set equal to edge underscore p1 dot get component vertex. And we're gonna have to we're gonna duplicate that all that entire line, do it like this. Now it probably would be a good idea to do some checks here. If underscore p1 dot get component vertex is equal to null, then we want to return and we can actually do an or edge dot get component vertex is equal to null. Then we can basically return out of this and not care. Okay, anyway, with that, we want to then do is I can actually do this now under not just get script. Actually, what am I doing? All we need to do is this. Okay. Under our vertex animate, all we need to do is do new edge dot add component. Believe it or not, this is actually the first time I'm actually doing this, a title edge. And hopefully this will actually get us the edge that we need. All right, so now we now need to create the edges. So for each, actually, let me do it like this. Let me grab this guy. And we actually need to create two edges. One specifically, one from here. Okay, I'll do it like this. One here and one here. That way, if we do that, we can actually do it. We can actually just basically get every single one of them. Like I said, my only problem is when we get to the ends where it ends up doing like that. So yeah, that's actually that's very helpful to know. And all we really need to do to get the next one is just add by one. So that's actually very simple. So let me go ahead and minimize some things. Otherwise, we're gonna get a little confused. Yeah. Let me also within the vertex field. All right. With that, what I want to do is make an edge I basically want to do is create edge. Okay, I just realized some stuff. I probably need to do a for each loop. Actually, no. I can do a for loop. For int I, this is equal to 0, while I is less than the animate vertices dot count. We want to do I plus plus. So first off, we take animated vertices I. Actually, what we want to do is create edge. We pass in I and I plus 1. Okay, but there are some very special circumstances. We need an integer for the row num, and we have an int for the column num. We'll set these equal to 0, so that way we can keep track of them. So now, in this case, we want to do row num plus plus. The end, and well, if row num is greater than, okay, this looks rather familiar if you ask me. If it's greater than this, but since it's starting at 0, it's actually kind of a little awkward. Hold on a second, the row number, a row number, and it has I can actually do something really quickly and make this a lot easier for myself. Okay, I'm gonna get, what did I just do? Okay. What I'm gonna need to do is, instead of making this a list, I'm gonna make this a dictionary. And this one is going to be a vector too. Guess what? We can have some coordinates. With this, we don't just have, we do this, we dot add, and we do the keys. And well, we don't just add it, we don't just add the vertex to this. When we create this vertex, we don't just add it. We, in a sense, I kind of need to get rid of this and just return the object. So I'm going to go ahead and have this return a game object. So a game object and return like so. Oof, okay, that's kind of be useless if you ask me now. Looking at it now, I feel like I don't need this function. Well, you know, I'll just keep it. I already made it anyway. And well, what we need to do is animate vertices add. We do this. However, we actually have some x and y coordinates. This is going to be equal to a new vector 2, and all this is going to be the x and y. Look at that. X and y, like this. Oh, x and z, my bad. Like that. And that's it. That's all we need to do. And well, we don't need to worry about it anymore. We can just do a for each loop here. We can do a for each we want to do game object vertex object in what is it? Animate vertices dot keys. Is it keys? Yep. It's game object. Okay. What we want to do here is we basically now need to reference. What am I doing? Hold on a second. Here. Okay, we'll do it like this instead. My brain is really exploding. My brain is exploding. Oh wait, okay, never mind. We let's just go back to what it was originally. Okay. So we have because the keys reference the keys are specifically reference the vertex. All right. So wait a minute. My brain. Oh my gosh. No, my brain. Okay. No, we actually want it to be the other way around. We want to get a reference from the key. We want to get we want the key to we want to switch it the other way around. I think it has to be the other way around. At least. And this one is not going to be, this is going to be instead a vector 2. This is and for each vector 2, this is going to be vertex vertex chord. We'll do it like that, vertex chord. Coordinate, why not? And well, this is not going to be keys. This is actually going to be the values. Well, in a sense, we need to have three references. The first is the vertex that we're checking, then the one in front of it, and the one on the next one, and this one and the two other vertices. So that way we can get some sort of squared kind of grid. All right, like that. Yeah, just like that. I'm gonna do something. I want to check something. Can I do if I do animate vertices and then I pass in a new vector 2 and I pass in a just make it 200 0 or something. You doing okay there, unit? You doing okay there? I want to see if Unity freaks out if I do this. I just want to check if it freaks out. If it doesn't freak out, then I'll go ahead and just continue on with what I'm about to do. Okay, it freaks out. Okay, yep, I thought so. So because it freaks out, we're gonna have to do a bit of some checking. Unfortunately, I now actually would like to do some sort of debug.log animate vertices x and animate vertices. Oh, x and z. I'm going to do plus, I'm going to have a space, and I'll do a semicolon plus x plus comma. I'll do it like this, plus y Let's see, plus this. You know what am I doing? I just need to do this. This is all I literally needed to do. Anyway. Hey, Unity, you doing okay? You don't look like you look like you're dropping frames. No, seriously, you look like you're dropping frames there. Okay, Unity, you're starting to creep me out. What? What did I? What? Wait, what? I'm confused now. Why is it null? Wait a minute, why is it null? What? What? Okay, I'm completely confused. Why is that null? Why? Object reference must set to is. What reference? This returns a game object. Create vertex. OBS. I'm sorry, not Unity. OBS. You okay there? You dropping frames. Why is it? What? What? Did I end up just deleting something? Create a vertex and return. Can I not do that? Do I have to? Please don't tell me I have to do this. This is terrible. Game object new v is gonna call. I'm gonna do it like that. We'll pass in here new v, and of course we can't forget the semicolon. I swear if it works now, I'm gonna be so annoyed. Still null. Why is it null? I'll just do it like that and hopefully it works. What? Hold on. Did I need to do that? Do I actually need, please don't tell me I need to do this. I swear if this is the reason why I'm going to be a little annoyed if I say so myself. Yep, and that was the exact reason why. Okay. So yeah, we actually don't need this debug log. I'm not gonna really leave it in there anymore. I'm just going to see, I just want to look here and see. So it starts. Why is it negative 15? Oh. Okay, so it goes all the way up to 20. Wait, no, I am stupid. Oh my gosh, why am I this dumb? Okay, I do not need this. I do not need, I'm overthinking. I am literally overthinking so badly. Okay, all I need to do is create edge, and hold up, I also need to do something, and this is going to be edge script.update trans, just like that. We're just going to do it like that, just to make sure. Okay, so we're going to create an edge, and well, the first point, I just might as well make it okay, we take in what? Okay, we're going through each of the. I'm trying to figure. Okay, what am I trying to figure out here? Okay, we have a reference to. Okay, let's say I have a reference to this vertex. Okay, never mind. We're gonna do it like this. So we have the animate vertices dot vertex coordinate. However, we also need to do something like that. We also need to do we have a vector 2. This is the horizontal underscore horizontal. This is the horizontal point, and we have the vector 2 horizontal. Then we have the we'll just call it vertical point, even though there's no vertical point, but whatever. Okay, we have a horizontal point and we have a vertical point. This is going to be equal to vertex coordinate dot is equal to a new vector 2. This point will be the vertex coordinate dot x plus 1, and we have 0, and this is equal to a new vector 2 vertex coordinate dot y plus 1. Hold on a second. The z is Okay, basically we want to make we also want an animate vertices, and we pass in the horizontal point, and then we do another create edge. It's actually very similar to this. All we need to do is duplicate this, and we take the vertical point. However, we need to do some checks. If okay, basically what we want to do is if vertex coordinate if vertex coordinate dot x, this is the column, this is our column. Okay, I'm a little bit triggered because the column okay, I kind of want to switch it around. Sorry, I'm thinking like tensors now. It can actually be like a matrix or some sort. I could think of it as like some sort of matrix. Okay, that actually is a very interesting way to think about it. It could be a matrix. Okay, so I can switch this to be the x, switch this to be the z, and all I really need to do is switch this around. Otherwise, because okay, I just want to think about it like a matrix. Hold on a second. Wait, no. Okay, it's still going to be like that. But the vertical point is still going to be this, and the horizontal point is still going to be this. What am I doing? I'm just making this more complicated for myself. Okay. But I really like the idea of having matrix stuff. Okay. So horizontal point is going to be this one. A 2D, this is actually a 2D matrix or whatever. Who cares? Anyway. So we have our x coordinate. The x coordinate, what it does, okay, the x coordinate is the row number, and the in the y coordinate is the okay. Okay. If vertex coordinate dot x, if the row number is equal to the vertex field c range dot y, and is not equal to that, then we'll do this. And then if vertex coordinate dot y is not equal to vertex field z range. Is it going to be z range? No, I think it's going to be x range is going to be the dot y. There we go. Makes sense. Hopefully I got it right and I don't just cause explosions on my end. All right. And we completely failed. Which key though? Okay, so yeah, that completely failed. Okay, so this is +1. Oh wait, no, this is supposed to be vertex coordinate dot y, and this should be vertex coordinate dot x. Maybe that will solve our problems? Maybe? All right, so that definitely did not exactly work out. Okay. But here's my question. Like, where is this of C? Okay, 47. X, oh, hold on a second. Maybe it should be the other way around. The Y, oh yeah, it should be like that. Okay, my bad. Let me go ahead and save. Oh, that is terrible. That looks, oh gosh. Oh gosh. Okay, I'm smart. Void start. I am smart. I totally didn't forget that edge script is equal to get component edge. Okay, hopefully, I hope that hopefully this is not going to lag. Oh, it's beautiful. Oh, it's so beautiful. It's beautiful, but I have a feeling the angle of the camera doesn't look very nice. I kind of, let me bring this up like this, and actually, how about we angle it slightly downward, like so. That looks beautiful. Hold on a second. I feel like I should move it a bit forward on the Z. Maybe like right. Yeah, let's do it like that. Yeah, it looks nice. I have a feeling I need to change up the capacity on these things. Okay, so with that, we have finally made some very cool looking. We made some very cool looking uh, title page. All right. Oops, I forgot to copy the values. Whoops. Okay, let me go ahead and do that again. Kind of curious. Is it better that it's like that you can see this thing, or I'm trying to, okay, I'm just right now I'm just trying to see if I can get this to look rather good. Nice looking. Some sort of, well, okay, I think I don't mind if you can see the bottom, but Just trying to make it look good now. No, we don't want to do that. All right. Oh, no. Oh, okay. I need to remember to do that. Right. I just need to remember. You know what? It looks fine. Now, maybe I'll change this up to 2.5 because it looked a little slow to me. It looks way too fast. 2? 2.75? I think 2.5 is fine. And with this, I feel like I want to try a wave amplitude of 2. Whoops. 1.5 is fine. I'm going to try a wave amplitude of this. All right, so let me try making this some sort of nice number, like 25 or something. Yeah, let's make that 25, all right? With that, I feel like I need to make the opacity of these, the opacity of this, excuse me, a little higher. Like maybe, let me try 200. Oh, 200 is actually still not enough for me. I'll do 225. The instructions, and we'll do 225. Let's try that. And if it's still, I don't know, I wouldn't know what to say if it still looks too much. I mean, if it's still, let me try 200. 200's readable. It's still fine. I think maybe just for those two. Okay, so on the title, we can have it be 200. Start button. I'll just leave it at 200. Okay, we'll leave it at 200, all of you. And it's been 2 hours and 30 minutes. Oh, gosh. We could do start, bring us here. And with that, we can return to the title screen. All right. Let me go ahead and build it and see what it looks like, because I'm really curious to see what it looks like. Let me get rid of this paint tool side without accidentally deleting something else. I'll do that, or closing something else. Okay, anyway, and with that, let's start. It looks beautiful. It looks so beautiful. Oh my gosh. It's so beautiful. Okay. I mean, look at it. It's so pretty. It's just a sine wave. It looks so pretty. I really kind of want to try and make it like the amplitude at the middle make it. I want to try to make the amplitude at the middle be like you know, some sort of something. Okay. I kind of wanted to do something like, because this is technically the title page is actually literally just completely cosmetic. It's nothing, it's not actually related at all to the actual thing. It actually, look, I have a feeling it's misleading. I'm a little bit afraid of that. It looks misleading as to what this program is, but it's called a shortest path solver. So what am I saying? I don't know. It's mainly just for show. It's not actually supposed to um, do something. Okay, anyway, with that, I, I don't know why. I really, really, really want to make I really want the amplitude to be determined by the amplitude, at least to be multiplied by the cosine function. I don't know why, but I really, really do. Okay. Okay, rather than like having it like that the middle doesn't even, I'm gonna actually just instead do mathf dot cosine of, and this one is going to be based purely on we're gonna do it like that, input value 2, and yes, and well, guess what, our input value 2 is actually going to be our object vertex dot transform dot position dot x, no z. Game object like so. And you know what? Wow, this is one long single line. Okay, anyway. Here we go. Hopefully it, I don't want to multiply it by, okay, I really do not want to do something like, okay, so this is what I want to do. I want to do it like that. Hopefully then it will be exactly what I want it to be. All right, so the ones in the middle, okay, that's interesting. It's actually should have been more of a sine function then. Order of operations, just do it to make sure. Okay, that is absolutely ugly. What? Okay. Because I'm trying to get rid of that little part in the middle there that's kind of well, those. I'm trying to get rid of like the ones where it's kind of zero. I don't know. I just want to see. I'm trying to. I'm just curious to see what, at this point what I can come up, what this can come up with. Uh, you know what? Fine. I won't have it like very pretty and thing where I won't have it be such that it does stuff. And I've been streaming for almost 3 hours. I'll just keep it like this beautiful thing. And well, yeah, I feel like this took a lot more longer than it needed to. Then again, I don't know. So that's the title page. You just need to give it the instructions, and hopefully, I can actually. I'm very certain I finished the title page. I just need to actually make the instructions. Um, some on-screen controls UI. Yeah, this is actually something I want to do. Uh, because okay, there's one part of the screen. There has to be some part of the screen that doesn't really get used much. And well, it's gonna probably have to be the one in the corner, the right, because it's. Uh, what I'm trying to do here is I want the people to, I just want them to know, to be able to see what the keys do. And well, I guess I have an idea. I actually have an idea. Yeah, I have an idea. It's going to be rather interesting if I say so myself, because I kind of need to make some sort of keyboard graphic and whatnot. Hopefully, I'll be able to make it, but I think I can do that off stream, and then, well, yeah. Yeah, I think it could work. My idea is that, or you could have like a cheat, like some sort of cheat sheet on the side here. Now I don't want it to cover. The thing is, I don't want it to cover too much of the screen. Otherwise, it's gonna be. I don't want it to cover like to be like too big, and then it's like distracting. I think, well, one thing I could do is have the movement controls over here, and yeah, yeah, this is kind of the one of the last things that I want to do because the instructions, Instructions is probably not going to be very interesting if I'm completely honest with myself. Uh, so yeah. Geez, I'm really trying to figure out how to. Oh, wait a second. I don't. Now I'm realizing I actually probably don't need to. Oh, this is actually kind of sweet. I have an idea. Uh, I'm not sure if I. Okay, like I said, I kind of want to finish this in 20 parts. I'm wondering if I should continue or if I should probably go to bed. It's like 5 a.m. I need to, yeah, you know what? I need to go to bed. It's 5 a.m. So in the next episode, I guess we're going to make I guess what we can do is we're going to make the on-screen controls. Because let's face it, yeah. And then after that, I'll go ahead and make some instructions. Sounds like a good plan. And well, yeah. Wow. I'm actually really surprised. Okay, I should mention that the instructions is actually I kind of want to make the instructions a completely different scene. Instructions scene. Actually, no, I don't want to make it a screen. Instead, I want to make it I probably want to just make it some very large UI thing and then instantiate it. Yeah, that's probably how I should do it. And then, okay, yeah. Okay, I'm brainstorming things, but I probably should go ahead and end things off now. So yeah, I have audio. Why is it telling me that the bit rate? Okay. So yeah, I am. Wow. I actually am quite surprised about what I've finished in this video. Then again, it's been a while since I've coded. I probably forgot some things after all. My brain is probably have been focused on other things. So yeah, finally we got this done. We have some rather interesting stuff, and well, we finished the title page. That's something that's very nice. And well, now all we need to do is to finally do this stuff. And I'm very certain that this is all I need to do. I don't believe that there's anything else that I need to do. I don't think so. So yeah, that's really about it for now. So thanks for watching and hope you enjoyed.